Okay, we're going to make a start now. So welcome everyone to our GCSE Maths session. In today's lesson, we are starting a new um, topic and we are looking at the volume of a prism. So over the next 5 lessons, we're going to be focusing on volume and surface area. We're going to be looking at some foundation questions and some higher questions over the next few weeks. Today is going to be crossover. Everything will be applicable for both foundation and higher. So we're going to start off by looking at cross sections. Then we're going to look at working out the area of compound shapes. Then we're going to move on to volume of a prism. And then I fitted in a short bucket because everybody enjoyed that last time we did it. And then we're going to look at some exam questions as we go through today's lesson. If you have any questions at any point, you can let me know in the Q&A, or you can let me know through the form. If you don't have access to the Q&A, you can scan that QR code and let me know any questions through the form. So we're going to start off straight away. So we're going to start off by looking at the cross section of a shape. And the cross section is just the 2D shape aspect of a 3D shape. And we're going to look at some examples now. So for example, over here, we all know that this is a cylinder. Okay, so we know that this is a cylinder. The shape over here is a cylinder, but what is the 2D shape in this 3D shape? So the 3D shape is the cylinder. The 2D shape is the circle. The circle is the shape which goes all the way through the 3D shape. The circle is the actual 2D shape that is just being stretched. So the cross section of this shape, this cylinder, is a circle because the 2D shape is the circle. If we have a look at this shape over here, we've got a cuboid, okay? And as we can see, the 2D shape over here in this case is a rectangle. The rectangle is the shape that's being stretched out into a 3D shape. So we know that this one is a cylinder. So we've got a cylinder. However, the cross section is a circle because that's the 2D shape that's being stretched. In this case over here, we've got a cuboid. We know that this is a cuboid. However, the cross section of the shape is a rectangle because the rectangle is the shape that is being stretched into a 3D shape. Okay, so the cross section is a rectangle. Okay, so all we're doing over here is we're looking at cross sections, and whenever we're working out volume, we're going to be looking at working out the volume of any prism. Any prism that you're given, you should be able to work out the volume of anything. And over here, we've got a 3D shape, we've got a cylinder, the 2D shape is a circle. Okay, the circle is the 2D shape that's being stretched. So the cross section is just a fancy word for the 2D shape. In this example, the 3D shape is a cuboid. However, the 2D shape that is present is a rectangle. The rectangle is the thing that's being stretched. So the cross section would be a rectangle. The cross section is just a fancy word for the 2D aspect of the 3D shape. Okay, so it's the 2D shape that is in the 3D shape. Okay, and we're going to have a look at some more examples as well. For example, you can have any shape. If I draw out a shape, let's say I had a triangle and I drew out a triangular prism. Okay, so this is my triangular prism over here. I've just drawn out my triangular prism. Now, what's the cross section of this shape? The cross section of this shape is a triangle because the 2D shape that's being stretched all the way through the shape is a triangle. Okay, so we got a good question over here. How do you know the cross section is a rectangle and not a square? The cross section for a cuboid can be a square as well. If you look at it from this angle, if you look at the cuboid from here downwards, you can see a square over here. Okay, so the cross section of the cuboid can be a square as well. It doesn't really make a difference when you're looking at exam questions. All you need to know is if you know the area of one face, you can work out the volume of the whole shape. Okay, it can be a square. The only reason I've said rectangle is because the front facing face, the face that we can see clearly in front of us, is a rectangle, and that rectangle is being stretched into a 3D shape. Okay, over here, the cross section is a triangle because we can see a triangle is present and the triangle is being stretched into a 3D shape. So this is what you call a triangular prism. Yeah, so for this one, you can have rectangle or square as a cross section. It doesn't really make a difference. Over here, we've got triangle as our cross section because the triangle is the one that's being stretched into a 3D shape. Okay, so it's just the 2D shape of the 3D shape that we're looking at. So in the cylinder case, we've got a circle. As you can see over here, we've got a circle. The circle is being stretched. Over here, you can have a square that's being stretched, or you can have a rectangle which is being stretched. Over here, you've got a triangle that's being stretched. So every time the cross section will be a 2D shape that you will know. It's like literally it will be a triangle, it can be a square, it can be a rectangle, it can be a circle, it can be a pentagon. If you had a pentagonal prism, which is very unlikely, you might see a prism like this. Okay, you might see a prism like that. That's a pentagonal prism because the 2D shape is a pentagon. Okay, the cross section of that shape is a pentagon, and that pentagon is being stretched all the way through the shape. Okay, so the cross section is just the 2D aspect of the 3D shape. Okay, so if you picked out any 3D shape, let's say I drew a cube. Okay, so we've got a cube over here. Now, as you can see, the main 2D shape that you can see in a cube is a square. So the cross section of the shape is just a square. The cross section is just a fancy name for a 2D shape. Okay, that's in simplest words you can have. It's a fancy name for a 2D shape. Okay, and it's really important when you're working out the volume of prisms. Okay, because the formula for working out any volume is this: the area of the cross section multiplied by the depth. And this will make much more sense when we look at exam questions. But the cross section, remember, is just the 2D shape. You're just working out the area of the 2D shape and then you're multiplying it by the depth. So if I gave you an example, let's say we had a cylinder. Okay, so we have a cylinder over here. Okay, I've just drawn a cylinder. What's the cross section of this cylinder? The cross section is a circle. So as you can see, the cross section is a circle. Now, because the cross section is a circle, we're going to work out the area of the cross section. So we're going to work out the area of the circle. And then we're going to multiply it by the depth. The depth is how much through the sheet that it goes, through the shape that it goes. So if we go across, that value there would get you your depth. Okay, so the depth is how much through. So if I drew a, if we looked at this shape over here, we know that the cross section over here is a circle. The circle is there present at the top. The distance the circle goes down, this distance over here, how much through the shape it goes, is known as the depth. Okay, so over here, if we had a triangular prism, we know that the cross section is a triangle. How much it is stretched is the depth. So this thing over here is the depth. How much it goes through is the depth. If we had a look at this, this is the cross section over here. This circle is our cross section. How much through the shape it goes is the depth. So this over here, the circle is being stretched by this much. So this is the depth. Okay, so whenever we're working out the volume of any prism, you work out the area of the cross section and then you multiply it by the depth. Okay, and the area of the cross section is just the 2D shape that you have. Okay, if you have a cylinder, the 2D shape is a circle. If you had a trapezoid, you have your trapezium as your main 2D shape. If you had a cuboid, you have your rectangle or a square as your 2D shape. If you had a triangular prism, you have your triangle as the 2D shape. Okay, so every time your cross section is just a simple 2D shape. You need to work out the area of your simple 2D shape and then you multiply it by the depth, how much through the shape it goes, the distance, how long it has been stretched. That's what you multiply it by. And this formula is very important. You will be using this formula to calculate the volume of any prism. You don't need to know any fancy formulas. As long as you know this formula, you can calculate the formula of any prism, the volume of any prism. Okay, so common formulas. So you'll know some of these already, but we're still going to go through them. Common formulas for working out the area. So remember, the first aspect is the area of the cross section. You need to know how to work out the area of a triangle, a trapezium, a circle, and a rectangle. Okay, these four are very key in order to work out the volume for a 3D shape. So first of all, if we start off with the triangle, to work out the area of a triangle, all you're going to do is you're going to do base times height divided by 2. And if I label that on this diagram, the base is just the bottom thing, the bottom line. This is your base. The height is the vertical line. Okay, so this is the height. Okay, this is not the height. The slanted line is not the height. The height is literally the vertical line of the triangle. So it's going to be base times height divided by 2. The height has to be the vertical line. Okay, of a circle, area of a circle is literally pi r squared, as you've probably heard from before. R is just the radius. So for example, that is an example of a radius. Okay, radius is half the diameter. It goes from the center of the circle and it touches the end of the circle. That's the value for the radius. Okay, so it's just pi times r times r. That's how you get the area of a circle. Pi r squared. For a rectangle, you're all probably familiar with this. The area of a rectangle is just length times width. That's how you work out the area of a rectangle. Your length is the longer side, so this over here is your length, and your width is the shorter side. So this is your width. You literally just multiply those two together to get the area of the rectangle. And then finally, you've got a trapezium. Now, trapezium is the one which many people struggle to remember. But first of all, a key fact that you need to know about a trapezium is that a shape can only be a trapezium if it has one pair of parallel sides. So as you can see over here, this side and this side, both of these sides are parallel to each other. Okay, they're both parallel to each other. Because they're both parallel to each other, this is a trapezium. Because this side over here, the side, this and this, they are not parallel to each other. They're bending inwards. So they're going to meet at some point. So they're not going to be parallel to each other. So this one is a trapezium because it has one pair of parallel sides. And what we're going to do is we're just going to label these parallel sides A and B in any order. So let's just label the top one as A and the bottom one as B. Okay, The formula to work out the area of a trapezium is A plus B divided by 2 times by the height. That's how you work out the area of a trapezium. And this over here is your height. Okay, so just remember, a trapezium, in order for a trapezium to exist, there has to be one pair of parallel sides. Okay, not two. If there were two pairs of parallel sides, it would either be a rhombus or it would be a parallelogram. Okay, it has to have one pair of parallel sides. So this shape over here has one pair of parallel sides, so it's classified as a trapezium. Okay, and all you're going to do is you're going to label what each pair, each side of the trapezium, each of the parallel sides, A and B. It doesn't matter which one you label as which, because you're just going to be adding them together. Okay, so I've just labeled the top one as A and the bottom one as B. All you're going to do is add together A and B. You're going to divide your answer by 2, and then you're going to multiply it by the height that you have over here. Okay, so that's how you work out the area of a trapezium. Okay, so those are the common formulas that you will be required to know. Yes, you might have seen a different way of writing this formula. You can also write half A plus B multiplied by the height. You can also write it like this. This is just another way of writing it. Um, Either of those works, but I just prefer this one over here. Okay, so common formulas: area of a triangle, base times height divided by 2, area of a circle, pi r squared, area of a rectangle, length times width, and then area of a trapezium, a plus b divided by 2 times the height. Okay, those are the common formulas that you will be required to know. Now, if we go back, why are we looking at these formulas? We're looking at these formulas because we need to work out the area of the cross section. And the cross section is always going to be a 2D shape. It's going to be some form of a 2D shape. Okay, and before we work out the volume of the 3D shape, we need to work out the area of the 2D shape and then multiply it by the depth. And this will make sense when we look at exam questions. Before we do, I have a question over here on an area of compound shapes. Before we move on to a volume question, I'm going to go through this example with you, and then I'm going to give you guys an opportunity to have a go at this question over here. So we need to work out the area of this shape. So this is not volume or anything. This is just compound shapes. A compound shape is when there are two shapes that are sandwiched together. When you have two shapes sandwiched together, you're going to get a weird looking shape like this one. What you're going to have to do, you'll need to work out the area of this shape. So the question says work out the area of this compound shape over here. How do you do this? Well, step one, all you have to do is you have to split the shape. Okay, you're going to split the shape, and you can split it in whichever way you want. Okay, so over here, I'm going to split it horizontally like this. I'm going to split the shape horizontally, because if I split it horizontally, I can see I formed a rectangle over here. We've got a rectangle and we've got a triangle over here. Okay, so I formed two shapes there. Now, what I'm going to do is I'm going to work out the area of this rectangle, and then I'm going to work out the area of the triangle, and then I'm going to add them together. Okay, so you split the shape, so you form two shapes. Okay, and then you're going to work out the area of each shape. And then you're going to add the two areas together. Okay, so we've split the shape. The reason why we've split the shape is so we can form simpler shapes. So as you can see, originally we had a random looking shape that we had no clue about. Now, because we've split it, that red line which I've split the two shapes with, you can see that we form two easier shapes to work out the area of. So we can work out the area of the rectangle, and then we can work out the area of the triangle. Now, to work out the area of a rectangle, we know that it's length times width. Okay, the length is 12 and the width is 5. Okay, so it's just going to be 12 times 5, which is going to be 60 centimeters squared. That's the area of your rectangle. So we've worked out the area of the rectangle. Now we need to work out the area of this triangle. Now, how do we work out the base of the triangle? That's a good question. So the way that we would do this is, we know that this whole distance over here, this red line, this whole distance is 12. That's the length of the whole distance. We know that this part is 7. Okay, this part is 7 centimeters. And now we're just left with this part over here, which we need to work out. That's the base of the triangle. Okay, so originally the whole distance was 12 centimeters. That's the whole distance. We know that this part is 7 centimeters. So that means this part must be 5 centimeters, because 5 and 7 gives you 12. If we add this to this, that gives you 12. So this base over here, this base of the triangle has to be 5 centimeters. Okay, now for the height of the triangle, we know that this whole distance is 9 centimeters. Okay, this whole distance is 9 centimeters. We know that this distance is 5 centimeters. We need to work out this distance over here. Okay, so the whole distance is 9. This distance is 5. So that means this distance where the arrows are, that has to be 4 centimeters. Okay, because 4 and 5 gives you 9. So whenever you're working out the horizontal sides or the vertical sides, you literally have to look, if you're working out a vertical side, you look at all the vertical sides, and then you can work out the vertical side. When you're working out a horizontal side, you look at all the horizontal sides, and then you can work out the horizontal side. So we know that this is 4 and this is 5. And then we know that the area of a triangle is base times height divided by 2. So it's going to be 5 times 4 divided by 2, which is 20 divided by 2, which is just 10 centimeters squared. So we've worked out the area of the triangle and the area of the rectangle. So now all you have to do is you have to add them together. Okay, so you're going to do 60 at 10, and that's going to give you 70 centimeters squared. Okay, so the way that you work out the area of these compound shapes is you split the shape, into two simpler shapes, and then you work out the area of the two simpler shapes. Once you've worked out the area of the two simpler shapes, you then add the two shapes together. You add the two areas of the shapes together. Okay, and to work out unknown lengths, the way that you would do that is, you look, if you're working out the horizontal length, you literally look at all the horizontal lines. So if I switch color, if I'm working out this length over here, to work out this length, you need to look at all the horizontal lengths. So you look at this length over there and this length. Those are all the horizontal lengths. And we know that the total length is 12, and we know that this length is 7. So that means this length has to be 5 centimeters, because we know that this length has to combine with 7 centimeters to give us the total length at the bottom. Okay, and same with the horizontals. Same with the verticals, sorry. Okay, so a question for you guys to have a go at. I want you to work out the area of this shape, and then I want you to type your answer in the Q&A, or scan the QR code and type your answer in the form. I'm going to give you guys around 1 minute and then I'll go through the answers with you. Okay, I'm just going to give you guys 30 more seconds and then I'm going to go through the answers. Okay, I'm going to go through the answers now. So we need to work out the area of the shape. Now, this is a compound shape. We've got two shapes sandwiched together. So the first step that you're going to do is you're going to split the shape. Okay, so step one is going to be split the shape. So we're going to split the shape and I'm going to split it like this, just so we can see two easy shapes come out. We can see a triangle and a rectangle coming out. So I've split the shape. Then what we're going to do is we're going to find the areas of each shape. So find the areas of each shape. So over here, let's work out the area of this rectangle first. Okay, so area of the rectangle, we know that the area of a rectangle is just length times width, and the length we know is 9, and the width is just 8. So it's going to be 9 times 8, and that's going to give you 72. That's the area of the rectangle, and then we need to work out the area of the triangle. Okay, so let's think over here. So we need to work out this distance over here. Now, because it's a vertical distance, we're going to look at all the vertical sides. So we're going to look at this side over here, that's a vertical side, and this side over here, that's a vertical side as well. So we know that the whole distance, as you can see, the whole distance is 9 centimeters. This whole big line, this whole distance is 9 centimeters. And we know that this distance over here is 4 centimeters. Okay, so that means that this distance that we need to work out has to be 5 centimeters. Okay, and now we need to work out the horizontal. So we need to work out this part. Okay, it's because this is the triangle that so this part of the blue line we need to work out. Okay, we know that so we're going to look at all the lines. So we know that all this distance over here is 20 centimeters. We know that the whole distance is 20 centimeters. We know that this much is 8 centimeters. We need to work out what's left over here. We need to work out this distance. Okay, so if this is 8 centimeters, that must mean that this is going to be 12 centimeters. Okay, because that's how much is left over. Okay, so because 8 and 12 gives you the whole distance of 20 centimeters. So you're going to work out the area of that triangle by doing 12 times 5 divided by 2. Okay, so remember triangle is base times height divided by 2. So you're going to do 12 times 5 divided by 2. 12 times 5 gives you 60. And then you're going to do 60 divided by 2, which is give you 30 centimeters squared. And then all you're going to do is step 3, add together the two areas. Okay, so you're going to do 72, add 30, and that's going to give you 102 centimeters squared. And that's what your final answer is going to be. 102 centimeters squared. Okay, so again, we work through that step by step. You split the shape first. You find the areas of each shape. Work out your missing sides. So over here, you needed to work out this length over here, and you needed to work out this length for your triangle. So the vertical ones, you look at the vertical lines. The total distance over here is 9 centimeters. This distance over here is 4 centimeters. The remaining distance over there will be 5 centimeters, because 5 and 4 will give you the total distance of 9 centimeters. If you split the triangle into a trapezium, into a triangle and a trapezium, that's completely fine. You should get the same answer as well. Okay. I split it vertically just so we have a triangle and a rectangle. But if you split it horizontally, if you split it this way, you could have also split it this way. That means you would have a trapezium. As you can see, you have a trapezium like that. You have your trapezium and you have your rectangle. You will still get the same answer. That would still be right. Okay. So that was just a bit on compound shapes. What we're going to do now is we're going to move on to a volume example. Okay, I'm going to go through this example with you, and then I'm going to give you guys one to have a go at yourself. Okay, so volume example. So remember what I said about working out the volume. There's a formula to work out the volume of any 3D shape. Okay, so the volume, to work out the volume, you have to work out the area of the cross section, and then you multiply it by the depth. The depth is just how much through the shape it goes, and the cross section is just the 2D shape. Okay, that's what we're going to do. So first of all, let's identify our cross section. What's the 2D shape? So as you can see, the cross section is a triangle. The 2D shape that we can see is a triangle. We can see that there is a 2D shape over here, and it's a triangle. So the cross section is a triangle. So what do we have to do? Well, we need to work out the area of the cross section. So we're going to have to work out the area of the triangle. Okay, so area of the triangle. How do you work out an area of a triangle? Okay, so area of triangle, that's just going to be base times height divided by 2. That's how you work out the area of the triangle. So over here, we can see that the base is 4 the base is at the bottom, base is the flat line at the bottom, that's 4 centimeters. And we know that the height is the vertical height. That's the actual height. So the height is 3 centimeters. This line, that this 5 centimeters, is nothing related in terms of finding the volume. Okay, so we know that the height is 3 centimeters and the base, the horizontal line, is 4 centimeters. So we can work out the area of the triangle by doing 4 times 3. So we're going to do 4 times 3 divided by 2. Okay, because the base is 4 centimeters, the height is 3 centimeters. You divide it by 2 because that's the area of a triangle. So 4 times 3 is 12. 12 divided by 2 is 6. So you have 6 centimeters squared for the area of the triangle. So we've worked out the area of the cross section. The cross section is just the 2D shape, and the 2D shape is a triangle. We've worked out the area of the triangle. Now what do we do? Now we need to multiply it by the depth, and the depth is how much through the shape it goes. So as you can see, we've got a triangle, and the triangle is going this much through the shape. Okay, so it's going 8 centimeters through the shape. So all we have to do is we have to multiply it by 8. The depth is 8. Okay, so we've worked out the area of the cross section. The cross section is a triangle. We've worked out the area of the triangle. The triangle is 6 centimeters squared. That's what we've worked out. And all you have to do is multiply it by the depth. The depth is how much through the shape it's going, and it's going 8 centimeters through the shape. So all we're going to do is we're going to have 6 multiplied by 8, and that's going to give us 48 centimeters cubed. Volume is always going to be in cubed. Area is in squared, and normal length is in log, so like sort of centimeters. So the total volume of this prism is 48 centimeters cubed. So you work out the area of your cross section, which is the 2D shape, and then you multiply it by the depth, how much through the shape it goes. Okay, so now I'm going to move on to a question that you guys can have a go at. This time you've got a prism and the cross section is a trapezium. Okay, so I want you guys to work out the volume of this prism. I'm going to give you guys 2 minutes, and then I'll go through the answers with you. Okay, I'm just going to give you guys 1 more minute, and then I'm going to go through the answers. Okay, I'm going to go through the answers now. So we need to work out the volume of this prism. So step one, the formula is working out the area of the cross section, and then we're going to multiply it by the depth to work out the volume. Okay, so that's how we're going to work out the volume of this prism. Now the cross section, what's the 2D shape? The 2D shape, as you can see, is a trapezium. Okay, we've got one pair of parallel sides. That means it's a trapezium. So the cross section is a trapezium. Okay, and how do we work out the volume? The area of a trapezium, we do a plus b divided by 2 multiplied by the height. And a and b are the two parallel sides in any order. So we'll just label this as a and this is b. So all we're going to do is we're going to do 4 add 8 divided by 2, and then we're going to multiply by the height. Now the height is just 7 centimeters, as you can see there. Okay, so we're just going to multiply it by 7. 4 add 8 is 12. 12 divided by 2 is 6. So we have 6 times 7, which is just 42. Okay, so we have 42 centimeters squared. Now we've worked out the area of the cross section. That's done. We've worked out the area of the cross section. We just need to multiply it by the depth. Okay, and the depth is just how much through the shape it goes. Okay, so as you can see, we've got trapezium. It's going this much through the shape. The depth is just 10 centimeters. It's going 10 centimeters through the shape. So all we're going to do is we're going to multiply it by 10. So 42 times 10 is going to give you 420 centimeters cubed. So that's your answer there, 420. Okay. So again, just to summarize there, all we did was we used the formula. Again, that formula is going to be key to any volume question of any prism. You work out the area of the cross section and then you multiply it by the depth. The area of the cross section is just the 2D shape. In this case, the 2D shape was a trapezium. So we worked out the area of a trapezium by using the formula a plus b divided by 2 multiplied by the height, and then we multiplied it by the depth, and the depth is how much through the shape that it goes, and it goes 10 centimeters through the shape, so we multiplied it by 10, and 42 times 10 gives you 420 centimeters cubed. Okay, now what we're going to do, guys, we're coming to the end of the lesson, so we're going to have a quick blockage of 7 minutes. Okay, so if you guys just want to go on to Blookit, either scan the QR code or go to blookit.com and type in those that code 4454713, and don't join with any inappropriate names because I will just remove them. just want to give it 30 more seconds and then we'll make a start. Okay, we will make a start now. So it's 7 minutes long, and there's some questions based on what we've done in today's lesson. Okay guys, you got about 5 minutes left. Okay, just under 4 minutes now. Okay, just under 3 minutes now. There's just about 1 minute left, guys. Okay, about 10 seconds left, guys. Okay, so well done everyone for having a go at that. Everybody's initials are um on the top three. So VSR, well done, third place, SR, well done, second place, and M, well done, first place. I hope you guys enjoyed that and got something out of it. You should know all your formulas now. Off the top of your head, you should know what cross section is, and how to work out the volume of a prism by the end of that blockade. So well done, guys, for having a go at that. What we're going to do now is we will end off for today's lesson on that note. We did have a couple of more questions, but we'll look at them in our next lesson as starters. Next lesson, we're looking at surface area as our main priority, but we'll have a look at some of these questions as well as starters in our next lesson. Okay.